Hi, welcome to Tech Talk with Dave. I'm Dave Clelland from MBSI Wave in Medicine Hat, Alberta. Topic today is going to be twisted pair cable. So we've been talking about what the OSI model, and we've been talking about the physical layer. And we're going to talk about a few different types of physical layer that commonly we use in broadband wireless and in fiber optics. So we're going to start here with twisted pair. So in modern systems, we have a number of different physical connections between devices that we commonly use. So UTP and STP, that's unshielded twisted pair and shielded twisted pair. Common between devices. I have a couple of routers sitting here on the table in front of me, and I have them connected together with a category 5 unshielded twisted pair cable. We also have fiber optics as a common method of interconnecting devices in modern broadband systems. Wi-Fi is a broadband PHY that's used in modern systems. It's real common to get the protocol and the other nuances of Wi-Fi mixed up with the physical layer, but the radios themselves, the transmitter and the receiver that takes and sends data and receives data, is actually a physical layer device. And of course, then in fixed wireless radio systems, such as Cambium's 450 or EPMP, for example, the radios in those systems are also the PHY layer that we talk about. All right, we're going to concentrate on twisted pair at this moment. So, as far as the PHY is concerned, the physical layer is concerned, if the physical layer isn't working well, then we have a huge problem in that all of the protocols and the events that occur higher up in the OSI model will also fail. So we need to have a very reliable connection in between our devices. In this case, between my two routers that I have in front of me here, I have this unshielded twisted pair patch cable. It's new. And so the connections are good, and this as far as the way the two routers are going to communicate with each other, this is very necessary. I call it here where the rubber meets the road for network operations. We have to have as reliable a connection as we can. To many technicians now, the PHY is a mystery. Often the PHY is connected to, in terms of thinking about it, it's directly related to its layer 2 or layer 3 system in the OSI model. And in fact, it needs to be treated separately. The physical layer needs to be treated separately from the data link layer and the transport layer that are above it in the OSI model. So here's some highlights of some common physical layer types concerning the twisted pair. So a typical connector is an RJ45. It's an 8-pin plug that has the pairs connected in a very specific manner. There's some standards for that. We're not going to go into those standards because that could be a course all on its own here for that. But typically, 100 meters maximum length between active devices. That has to do with how fast the signal travels down the cable. Has to do with timing. Each color pair has a slightly different twist length, meaning that the twists are not all uniform within this cable. So there are pairs with a very tight twist, and there are pairs with a relatively loose twist. The RJ45 interface on active devices is isolated from the device itself. In the case of my routers here, there is no physical connection between the interface that my cable is plugged into and the integrated circuits that are forming up the signal that's to be transmitted or to be received on the board. So RJ45 Ethernet type of interfaces, if that's what we want to call this, the physical layer is isolated from the device that it's connected to. So oftentimes if we're going through a high static environment, for example, up a tower, for instance, the surge protection that we put on the physical layer on the cable itself can take a static discharge. It can short to ground. It can be protected. It can do all sorts of things and not affect the devices on either end as a rule. However, it is often the case that when the physical layer takes a hit of some sort, that isolation breaks down, and then we have to replace the interface, or we have to replace the device. But anyway, I've got a typical color code that's used for TIA 568A, one of the standards that is implemented in Unshielded Twisted Pair. And you can see we've got two types of cable. We've got a straight through cable and a crossover cable. We hardly use crossover cables anymore. Once upon a time, devices were either a data terminal equipment or a data communications equipment. And so the data communications equipment was meant to connect to a terminal equipment. If we were connecting two communications equipment together, two DCEs together, then we'd use a crossover cable. But these days, generally Ethernet ports detect what they are and become the opposite to what the other end is, and they just automatically connect up. All right, so twisted pair principles. The actual signal in this cable is analog. It's not digital. This analog signal is sent up the cable on either 2 or 4 pairs, and it's modulated onto each pair that's used. And so typically, in a gigabit connection, each one of these pairs are used. Each one of these pairs handles up to about 250 megabits, actually a little higher than that, 250 megabits of analog data across the link. The data is converted from digital to analog in the interface itself, then sent to the other end, then decoded at the other end, and recovered from the analog signal that it receives to a digital signal that the processors can use inside of the device. So, why? So, if I had a pulsed DC cable here, in other words, binary, if I was sending digital signals down this cable, the distance that I could send that would roll off very quickly. What happens is if I send a pulse into a cable, that pulse, as it travels down the cable, capacity and the inductance of the cable itself, a little bit of electronics here, will tend to round off that signal. So if I have a square wave coming into the cable, I will end up with a much less than a square wave coming out of the cable. And so that limits the distance that I can send the cable and recover that data from. With alternating current, with AC traveling down, the analog AC traveling down the twisted pair, the two magnetic fields tend to cancel each other out. There's a magnetic field around each conductor. The AC tends to cancel the magnetic field out from the other one, so there's less influence between the two pairs, and I can send that signal over a much larger distance. And in my case of Ethernet here, the standard is 100 meters that I can take and send this signal and recover it, and more importantly, do all the other things that I need to make sure that the timing stays accurate, that synchronization that we talked about before is working. All right. So twisted pair cables are identified by the category that they are. So the category 3, old-fashioned telephone cabling, is generally 2 pair. And yes, they're twisted, but they're designed more for audio on the cable rather than a data signal on the cable. When we get up to Cat 5 and Cat 5 extended, Cat 5e, we have the 4 pairs in the cable for starters. The twists are different for each of the 4 pairs. This is where we come up with that, so that again the magnetic fields between the cables tend to cancel each other out, and so we have less magnetic interference between the conductors and the cable, enhancing the data carrying capacity of it. Now we get to Cat 6. Lots of times there's a bit of confusion between Cat 5 and Cat 6, but essentially the difference between Cat 6 and Cat 5 is that in Cat 6 each pair is separated in the cable into its own tube, or it's divided. And so the pairs are held apart, reducing again the crosstalk, the interference between the pairs, and in fact enhancing the speed that we're able to take and send the data down the pairs. Now, one of the other things that, because of the fact that the twisted pair phi is separated from the actual device that it's connected to, we're able to take and put power over this and actually power the device at the other end. So we have some standards that we have with power over Ethernet, and I've got a table here that lists the standards. I'm not going to go through them, but you can take and see what the voltage, what the standard, what the power level of each of these standard types is designed to handle. So today we can take and generally provide up to 90 watts of power at the other end of a unshielded twisted pair cable, which is pretty remarkable. So for those of you who are familiar with electronics, this is typically how the power is injected onto twisted pair and how it's recovered at the other end. So on the left hand side we have the power supply, the controller, and it's taking and adding voltage to the center tap. In this case of transformers, it could be the center of a couple of opto-isolators. In this case we're showing transformers here, and so the data on each pair is the same polarity going to the other end, but we use 2 pairs to send the positive and the negative to the other end. We recover them with a diode bridge. Usually that's in just a single integrated circuit, and then we recover that DC at the other end and have the voltage to power the device. And so PoE is always one way. There's always a power supply, a PSE controller that is sending power to a device that's receiving it. So in many times in our case, the power supply controller is the switch or the PoE brick that's located at the base of the tower, and then the PoE is sent up the Cat 5 cable to the access point or the device that's up the tower to be able to power it up. Same thing goes with cameras, with all kinds of devices that will use power over the Ethernet in order to take and drive themselves. So there's two, really, as far as PoE goes, there's really a set of standards, and then when there is no standard, it's called passive. And so passive PoE, you need to take and make sure that the device that's doing the powering is compatible with the device that's receiving the power. There are things like you have to watch which pairs are positive, which pairs are negative. Whether it's using all 4 pairs or it can use 2 pairs for power. Typically, in the past, we've used 2 pairs for power, but as power requirements go up, we need to use all 4 pairs. But passive is very popular in that we can tailor the power over Ethernet to the device that's connected at the other end, and from a manufacturer's standpoint, it is just a little bit easier to do that powering rather than using one of the PoE standards. However, they're both important. It's important to know that both exist, and that we need to use the PoE standard when it's called for. We need to use passive PoE when it's not. So as always, we love your feedback, we love your comments, and we love new topic suggestions. Send an email to marketing@mbsiwave.com, and I look forward to our next session together.